Welcome everybody. This is chapter 6, section 2 for solving systems with substitution. This is a really important section, and it's just important because of the math that we do. This is kind of a math that you can do in lots of different situations, so really need to make sure that we get this down and study your notes when we're done. Ask questions. Please make sure you get a hold of me to get some extra help. But this is really a big part of math here. And you've done this stuff before. You've done substitution is the biggest thing here. You've done this before, so it's just applying this to a different kind of situation. Last section we learned about finding a point on a graph by graphing two equations and seeing where they intersect and grabbing that point using it. Well, now we're going to do that same thing, but we're going to do it by mathematical substitution. Okay, so we're going to start off with, if you could write this down, if y does equal 4 and x plus y equals 10, we want to solve that for x. Okay. All right, so if you write that down, once again, too, if I get going too fast on the notes, hit pause and then get caught up and then come back and hit play and we'll get going, all right? So let's take what this is really, for. We're going to, they're telling us that we want to find x and y equals 4 and x plus y equals 10. So let's substitute, what y is. We're going to take y as 4. We're going to substitute it into the equation, okay? This math lets us do that. Something's equal to something, you can replace it. And then the question is, what is x? So to solve this for x, just like, we've been doing all year long, I can get rid of the positive 4 by subtraction, and I get x is 6. So that's substitution. I can replace things for others, and in this case I can solve something. Okay, so pretty basic explanation of what substitution is. Now we're going to use it and kind of step up our game a little bit. Now I want to make sure we understand something here. First off, if you could write these two equations down. Last section we could have graphed these on a graph. They're not giving us a graph, so now we have to actually find the point. So whenever you're doing systems, you're always looking for a point, okay, x and y value. You can do that by graphing and see where they intersect, or now we're going to try it mathematically. Okay, I want you guys to understand something before we get going. If you can agree with this statement, does y equal y? And I hopefully you say yes. And does x equal x? Well, yeah. Anything equals itself. 1 equals 1. 5 equals 5. Negative 10 equals negative 10. You can keep going. Something always equals itself. Okay? So if that's true, if you guys are okay with me saying that, you guys agree with it, is this y and is this y equal to itself? And I hope that you say yes. And technically, this x right here and this x right here is equal to itself. We just don't know what they are, but they're equal to themselves, okay? So let me get rid of this mess right here. Okay, now, if you're agreeing with me, and hopefully you do, trust me, okay? If these two y's are equal to each other, okay? But up here, y equals this. Well, whatever y equals, can't I replace it into y down here? Okay, now I'm going to go back to where we started. You guys let me do this. Y equals 4. It doesn't matter what y equals. If it's something, it's something. Was I allowed to replace it wherever I saw another y? And we did. So what I can do here, since I've got this situation right here, I'm going to go ahead in that second equation and take that y out and put in x. Okay. Why did I do that? Well, because in this equation I couldn't really solve it for x or y, and the same thing here. But now that I replaced one of the, in this case, the y's, can I solve this now for x at least? And I can, okay? Because now I've got the same variable throughout the problem, and now I can do that. So 1x plus 3x is 4x equals 32. And then I can divide both sides by 4, and I get x is equal to 8. Well, that's pretty cool. Now I got a value for x. Remember, what I'm trying to do is find a point. Well, I've got my x value now in that point. So I'm going to go ahead and start this. I got a point going. I just don't have y. Well, how do I go find y? Well, I'm going to go back and clean up my mess again. Okay. Do you think if I took this x equals 8 and put in for x here or for x here, do you think I could solve it for y? And you can, because that's substitution again. I'm replacing something with something else that's equal. X is equal to 8. Okay. Now you have a choice. Do you want to put it? Do you want to put x in this equation, or you don't want to put it in that equation? It doesn't matter. So I'm lazy. I don't like to do a whole bunch of work. So which equation is maybe the easiest to plug in this 8 for x? Well, I think it's this guy. Okay. Like I said, it doesn't matter which one, but I'm going to plug it in for that. Okay. So now can I solve this for y? Well, yeah, it's pretty easy. 3 times 8 is 24. Okay. Well, now I got a y value that I can plug in to get a point. Okay. So 24. And that's my point. Okay. Now that's my point. And if you're in the last section, that's where my point would have, whatever the equations were, that's where they would have intersected. Okay. That would have been the intersection point represented by that. So that's if we had graphed it. And you could have graphed it, but you're not always given a graph, and then you got to look for accuracy too. So we're doing it mathematically. Okay. If you took these 2 points, or the point, the x and y values, and you plugged them in for y and for x, y is 24, and x was 8. Are they equal to each other? Well, yeah, 24 equals 24. Okay. And that's the way to kind of double check that you got that correct. Okay. All right. Very good. Okay. We're going to go here, and we're going to solve this. Okay, you could write down this equation, that equation there. Okay, now that we do a nice, I think, an easy equation up there. Now we come here and we kind of go to the extreme. This one's going to be kind of tough. Okay. Now, to be able to do what we did up there, one of the x's and one of the y's has to be isolated. Okay. And you get to pick. This is good. It's kind of nice in this chapter. There's some, you get to kind of look at things and be able to pick how you want to attack the problem. Now, unfortunately, to get good at that, you have to do a bunch of these, okay? And you kind of get an idea how these numbers work together and what ones will work for you, okay? So, let me go back. So like this one, y was by itself up in that equation, so that was an easy way for me to kind of go, hey, let's substitute. In this case, it's not. Okay, so you have to look at it and kind of decide how you want to get something by itself. So I'm just going to, if you can trust me here, kind of just follow my lead for a little bit. This equation right here is going to be easier for me to isolate either the x or the y. Okay, and the reason is that at some point to get one of them by itself, I might get a fraction in front of the x or y, and I don't want to do that. Okay, so what I'm going to do is try, and you get to pick, but I'm going to try to get the y by itself. Okay, so the first thing I'm going to do is add 2x to the other side. Okay, I'm then going to get 2y equals 2x minus 6. And then to get y all by itself, I'm going to divide by 2. Okay, so y equals, that's a 1x, sorry, that's a 1x minus 3. Okay, did I get a variable by itself? I did. Now y equals this, okay? So we got it. This is the trust thing here. Y equals that. It's not like y equals 4 or y equals 3x. Now y equals some kind of expression, x minus 3. Okay? Now, if you'll notice in the second, or actually really the first equation, I have a y. And, you know, this y and this y are the same. And I've solved for y down here in that second equation. So can I take this and plug it in for y up here? And the rule that we've been working with is, yeah, you can do that. So let's watch this. So I'm going to take that 3 that's in front of the y, but I'm going to take what y equals down here and plug it in. Okay? And then I got to finish up the rest of the equation. So plus 4x equals 12. Okay? All right, now that's called substitution. Y equals something down here, so I can replace it. Wherever I see a y, I can put that in for the other y's, y or other y's that I see. Okay? Now substitution to me is actually kind of easy, but it seems to be difficult for a lot of people. And really it's because you're trying to stick different things in for different places, and that can get kind of confusing, but it's actually, I think, relatively easy. Okay, so what I'm going to do here is I'm going to distribute this 3 through. Okay, okay, and now I hope you're seeing this allows me now to solve for x. If I went and looked back at these two things, there's, you know, you're looking at how do you solve it and get a point out of that. Well, there's different things you can do. This is one of them, substitution. But to do that, you have to get the same variable throughout the whole problem to do this. Okay. So now like terms you can put together. So this is something we struggle with sometimes. You're trying to solve for this, but there's stuff I can put together first before I solve. So 3x and 4x is 7x minus 9 equals 12. Okay, and now I can add 9 to both sides, and I'm going to get 7x equals 21. And I can divide by 7 both sides, and I can get x is equal to 3. Okay. So now remember all this work, you're still trying to find a point, the x and a y value. Well, I've got x is 3. Okay? But I still need to get y for my point. So remember, you've solved it for x, and now I can use substitution again. I can go back and let me clean up my mess here. I can go back to my equations, and wherever I see an x, I can plug it in, and now I can solve it for y. Now this is one of the things that's this kind of math is you get choices here. You can plug it in here, or you can plug it in there. You get to pick. Now, with I don't like negative numbers. Sometimes we make mistakes. Okay, so you can have a choice of plugging it in there or there. I think I'm going to go and plug it into the top. You can plug it in wherever you want. Okay, so 3y plus 4, and now x is 3 equals 12. Okay, 4 times 3 is 12 equals 12. Now I'm solving it for y, so I'm going to get rid of the 12, and I get 3y equals 0. Okay, now some kids just stop right here and go, it's nothing. But, you know, anything divided into 0 is going to give you 0. Okay, so there's my y value for my point. So I can go ahead and put 0 in for y. So there's my answer, 3, 0. Okay. Now you gotta do a bunch of these, and you really got to use the notes here. Try to be clean, but there's not a whole lot of room here, so I apologize for that. But you can get good at this. It's really not that difficult. It just takes some thought, and then once you do a bunch, and you kind of get some rhythm to this. It actually gets kind of easy. Okay. Okay. So we got a couple of word problems that go here that you know, how do you apply this is kind of how we're going to do this. All right. So we got a large. We got these snack packs. We got a large one that's $5 and a small one that's $3. Okay. And we're going to sell a certain number at a certain amount. Okay, so let's just do this. Let's call the large ones X and the small ones Y. Okay, and what you have to do is you have to set up 2 equations. So write this down. 2 equations. And in this case, it's the one of the equations is the amount sold. And so if you read this equation, we're going to sell 60 packs. And then you're going to have an amount in dollars. Okay, so we sold them for $220. Okay, so let's set these up. The first one is the amounts that were sold. I got X large ones. I got Y small ones. Gives me 60 total sold. Okay, then the dollar amounts. I mean, still using X and Y. But the large ones were $5, small ones were $3, and it equaled $220 that I made. Okay. All right. So that can be kind of hard. How do I set these up? Okay. Now what you need to do here is remember what to do substitution. I'm trying to isolate one of the X's or the Y's in one of the equations. Well, which one do you think would be the easiest to isolate one of the variables? Okay, well, to me, I think the top one. And which variable do you want to isolate? Well, it doesn't matter. You get to pick, so that's kind of the nice thing. Okay, well, let's isolate X. We'll do this together. Okay, so what I'm going to want to do here is isolate the X by subtracting the Y. And that's going to give me X equals 60 minus Y. Okay. So, is this X down here and this X that I just isolated, are they the same? And yes, they are. Yeah, this one's got 5 in front of it, but that doesn't matter. It's the X's that I'm looking at. So what that's going to allow me to do is take that X out and plug in 60 minus Y. Okay, into that second equation. Take it out and replace it. That's what substitution is, as long as I got something that's equal. And that's what we did right here, okay? So we're going to have to go distribute this, okay? So here and here. 5 times 60 is 300. 5 times negative y is negative 5y. plus 3y equals 220. Okay. I'm going to kind of slide over here. Typically, when you do these, you're going to have some like terms to put together, and typically it's going to be the variables because you're going to have more than one. So when I put those together, negative 5y plus 3y is negative 2y equals 220. Okay, I want to isolate the 2y, so I'm going to subtract 300. Goes away, so you're left with negative 2y. Don't forget the minus sign. And 220 minus 300 is negative 80. And then you're going to go ahead and divide both sides by negative 2. Okay, so y equals 40. Okay, so that's one of my points. But I got the y value this time. I'll need to get the x. So you got one of your solutions or one of your parts of your points, and you need to go get the x. Now, remember the nice thing here, I have to go back and plug it back into one of the equations. Well, which one do you think is the easiest one to plug into? Well, I'm gonna have to go with the top. Okay. It's just 1x plus 1y equals 60. I got y, so I'm going to go ahead and plug that in. X plus 40 now for y is equal to that 60. I'm going to subtract 40, and x is 20. Okay. So remember, if we go back to our original problem, the largest we called x, the smaller ones we called y, and they sold it for $220 total. They sold 60 packs total. But the question is, how many small snack packs did they sell? Remember, small was y. We found that right here. We could have answered the question at the very beginning. Okay, but I just want to go all the way through the problem so you kind of see how to work it. Okay. And that's another thing too, a point that I can make is that when you get really good at this, you're looking at this word problem and you set it up like we did. Sometimes, if you really read the question and you get good at this, you can pick out, hey, I only have to do one part of this and I'm done. Okay. All right. So that's how you do that. You guys will finish it up with this. These are specialty equations. Okay. All right, and I'm going to show you a little trick here too on this. So let's do this first one. If you could write both of these equations down, please. This first one here is kind of nice because they already isolated a variable for us. So that means I could take this, x equals this, and I can plug it in for x right there. Okay. So we're going to go 3.5 and in parentheses. So whenever I replace something, I put replacement in parentheses, typically. So I'm replacing it for x in the second equation, just taking it out and putting something else in. That just gives me y throughout the problem, okay? So I'm going to go ahead and I'm going to go here, multiply that out, I get negative 7y. 3.5 times 2 is 7, but signs are different, so it's negative. 3.5 times 4, and that gives me 14, plus 7y equals 14. Okay, so make sure you distribute it properly and make sure you're good with your signs. Okay, typically, like we've done before, I can probably put some stuff together. So negative 7y and positive 7y is 0. 0 plus this 14 is 14, and 14 equals 14, okay? Now, in the other problems we've done, you've always found an x and found a y. Well, now they're all gone. Is that true? Yes, it's true. So sometimes when you get these problems and you get something like this, and it's true, this is all real numbers, okay? So basically it means that these these two things, if they were lines where we put them in y equals mx plus b, they'd be the same thing. So it's like two lines sitting on top of each other, if you remember that from section 1. Okay. So a little trick here. Let's do this. This is kind of another thing you can do with substitution. I got y by itself. That means I could take this 3x minus 11 and plug it in for y here. But I'm gonna show you something you can do on your own. What I'm going to do is get this y isolated. So I'm going to add 3x to both sides. Okay. So when I do that, I get this. Okay. All right. Now I'm going to take this and rewrite it down here so you can see hopefully what I'm talking about. Are these two y's the same? Yes, they are. This y equals that. This y equals this. So does y equal y? Yes, it does. So can I take those two different things instead of equal to each other? And I can. Okay, so it's a different kind of substitution. All right, now I'm going to solve it for x now. So I got it on both sides. I'm going to subtract it. That goes away. I get negative 13. This goes away, I get negative 11. Is that true? No, it's false. Negative 13 is not equal to negative 11, so that's false. So what that answer tells me here, that those two lines are parallel lines. And parallel lines do not have a solution. Okay, so those are the unique things that show up occasionally when you're doing these. We just need to know what my real answer is. This is my answer here, and that was my answer there. Okay. All right, so that's a really good section, substitution. You really just need to do a bunch of the classwork and get really good at it. It can be frustrating at times, and because you can sometimes pick, sometimes I'm not really sure what to do. Don't sit there and think too much. You're trying to isolate one of the variables. It doesn't matter which one. It doesn't matter which equation. Hopefully you get good at it. You make it easy on yourself and kind of cut the work, okay? Please make sure you get a hold of me if you need extra help. But give your classwork a chance. Give it a legit shot and try them, okay? All right, so get a hold of me if you need something, but do a good job on your work. Take care.